I'm James Auger. I've been at MITI for 3 years. Background is in originally product design, but I would say since early 2000s shifting more towards critical design or speculative design as it's become known more recently. We have one major project here that came out of what we started to call the Reconstrained Design Group, and it looks at the constraints that exist in life that we take for granted, certainly as designers, but also engineers, as people who plan for futures and so on. These constraints limit our potential to operate in certain ways. The main constraint that we were looking at with this project was energy and its infrastructure. So being on a sunny island, and quite often a windy island, we imagined when we first arrived that it would be a great place for renewable energy. But a little bit of research showed that although it's very easy to generate renewable energy, it's very problematic, not just here but all over the world, because the companies that own the infrastructure don't like the business model that renewables bring about. It makes it harder for them to make money. And as a result, they put barriers in place. They use the infrastructure as a constraint to really stop people using renewables to the full potential. So that was the origin for the project. We wanted to find solutions to that, and this is one version of that solution here. It's a gravity battery. So what that is a storage device. When we're generating electricity through solar panels, for example, normally that energy has to be used in real time, so you use energy as the sun shines. The alternative is to sell it back to the grid, but the grid doesn't like to buy the energy. So in this case, what we're doing, rather than selling it back to the grid, is we're using the solar energy to lift a weight into the sky. So this is just really a very early version with quite a low weight. This is around 20 kilograms. But as we got better and a better understanding of the systems, we've been increasing that mass bit by bit by bit. The key thing, really why this makes sense in Madeira, is because it's very vertical. If you look around the island, you'll see lots of cliffs and cliffside communities. And what that means is you've got a lot of height to lift that weight up. And the more height you can lift it to, the more potential energy or the more stored energy you have. So the idea is solar energy lifts the weight into the sky, and then when you need the energy, when you come home from work at the end of the day, perhaps it's gone dark, you can release the weight falls, and it turns this motor at the top in reverse, which is a generator, and gives you the electricity back. So this is all open source. It's all based on community involvement. We've been doing some experiments with communities. We did a 1-week project in the Scottish Orkney Isles where we arrived with absolutely nothing, and through working with local people for that week, we found the tools, we found the materials. This one is using a scrap motorcycle gearbox. We found the equivalent version on the island, and in 4 days built a working gravity battery with the local people there. So with this, we've just won another grant to take the project forward for another 3 years. So we're going to continue with some more experimental ways of storing energy. We'll probably do something with the lavadas. But there's another side to the project. This is very utilitarian. As you can see, it doesn't look like a domestic product. It's a functional working device. So we have another side to the project, which is using a similar principle, but to develop high-end quality domestic products like record players and lamps and different things, where normally, if I'm a practicing product designer and the company commissions me to develop a product, let's say a kettle, I'll design the kettle, I'll put the handle on there and a switch, I'll look a little bit at the electrical system and how the element works, and there'll be a cable, and at the end of the cable is a plug that plugs into the wall, and that's all I have to care about is the product to the end of the cable. I don't have to think about the energy. But with these new products that we're developing, the product is the entire system, not just the product itself, but also how it generates its own power. So using a similar principle to the gravity battery, we're having these devices that all of the energy is contained within the object. And likewise, with this being a community-based thing, everything would be open source. If you want to buy one of these gravity lamps, for example, you don't go to a shop or you don't order it online, but you become almost a project manager. You can either build it yourself if you have skills and access to the tools, or what we'd like to do is invigorate local manufacturing, like the local wood shops and the local metal yards, and they would hold the instructions and you'd go and order various parts from local makers, and then there might be somebody assembles it or you assemble it yourself. But it just really challenges and changes the infrastructures through which products arrive in our lives.